just now, Professor Zhang talked about the variability for winter. I'd like to talk about predictability for summer. So the title is the predictability of summer climate in the Western North Pacific. I'll talk about these kind of things. First, is about the motivation. We all know that actually over this period, we have a great year-to-year variability for the summer precipitation, including over the East Asian country, and also we have another great variability over Western North Pacific. So in this study, I'd like to focus on Western North Pacific. Although there's not so many people expect the Philippine people, actually there's no many people living over Western Pacific, but the precipitation over Western North Pacific is very important for the variability, precipitation variability in East Asia. They can affect the East Asian climate significantly, and also the rainfall variability over Western North Pacific can act as a linking role, linking the answer to the East Asian climate. So I will focus on the Western North Pacific summer rainfall. And if we look at the predictability produced by AGCM and also by CGCM, we can find that actually over Western North Pacific, the CGCM is much better than the AGCM. We can find that it's covered by red, but this is almost zero. So all these studies show that the coupled model is much better than atmospheric model alone. So in the next, we will use the coupled model. But in addition, if we look at the predictability over lands, we can find even the coupled model cannot predict the precipitation over land well. And another one is we know that very well that there are some significant decadal change happened in East Asia and also over Western North Pacific. For example, during this period and also this period. Professor Zhang's here. And also some change, significant change in the relationship between answer and monsoon. So in this talk, I'd like to also talk about the decadal change in predictability. So this is the main question of the regarding this talk. The model we use, or they came from the ensembles. It's a European huge project, and in this project, we only focus on this part, and this part actually includes the seasonal to decadal hindcasts. But in this study, we only focus on the seasonal hindcast. for some variability. Let's start from May 1st, and for each year, they have 9 integration. So by using 5 models, so for each year, actually we have the 45 predictions. These are for the 5 individual models, and if we focus on the ensemble, the MME result, we can find the, over the Western North Pacific, it's covered by red. So that means that there is the relatively high predictability over Western North Pacific. This is for the zonal wind to the lower level. It also shows the high predictability over here, this region. If we look at the so-called the monsoon index, this is followed the Binoang and the Fan. We can find that the model basically captured the monsoon index variability with the correlation coefficient near to 0.7. And if we look, compare with the statistical the model result, we can find the ensemble result is comparable to the statistical model. So that means that the ensembles, ensemble's performance is quite good. During the 46 years for the hindcast, we can divide these years into different answer phases, and here list the different answer phases, including neutral. That means there's no significant answer signals for these years. And if we look at the model performance for each phases, we can find exhibit this one. That means La Nina decaying. For the La Nina decaying phase, the model can predict the monsoon index quite well. Even for neutral phases, the model can predict the monsoon variability quite well. That means that currently the coupled model can capture quite well the LC interaction. And this one indicates the ensemble mean, and each clause indicates the model output for each model. So from this figure, we can find that for each phases, including neutral phase, all the models show the same result. So expect the La Nina decaying. Some model is good, but some others are extremely poor. So this figure shows that the predictability is actually depend on the answer phase, but they performs quite good. Expect the La Nina decaying. And next, I'd like to talk about the decadal change in prediction skill. For the 46 years, if we divided them into 2 periods, the first one is before the end of 1970. We can find the skill is quite low in compare with the afterward period. But if we divided the later period into two smaller periods, then we can find that there's also some decadal change happened around 1993 and 1994. It's much higher after the 1994. If we look at the running correlation coefficient, shows a similar result. And just now I showed the ensemble result. If we look at the result for each model, we can find all the models show the similar decadal change. Decadal change around this period and also this period. All the models show the same decadal change. And if we look at the why such kind of decadal change happened, we check the first we check the zonal wind predictability and also SST predictability. We can find that after this period, the SST predictability over Indian Ocean is higher than before. If we look at their difference, just use this one to minus this one, we can find that here the SST predictability is improved significantly. And if we look at the next decadal change that happened around this period, and here shows the afterwards, and here shows the earlier period for the earlier period. We can find that for the SST anomaly, the predictability, it's not so good in compared with this one. So for this decadal change, the SST predictability over Indian Ocean is not a reason. There must be some other kind of reason. And here shows that some previous studies on the 1993 and 4 decadal change, they suggest that this kind of decadal change is related to the change in mode. Before the before the 1993, the mode is something like the El Nino related mode, and afterwards it's related to such kind of SST anomaly, negative here and positive here, quite different. The before and after period. If we look at the model results can also capture quite well such kind of decadal change. And the previous study showed that for this period, the Western North Pacific summer monsoon show a great variability. That's the reason for we can capture the monsoon variability better. And if we look at the predictability change, then we can find just as I mentioned, the SST predictability actually is decreased. So it's not the reason. But if we look at here, you can find there is a positive values. That means the SST over here is it's associated with the enhanced predictability over here. So that's maybe the reason. And finally, I'd like to talk about the precipitation over land, because it's as I mentioned that it will be very difficult to predict the rainfall anomaly over land. So here we used another prediction system. Actually, GROSI-5 is the newly operational prediction system in UK. And my institute have a collaboration with the Hardlight Center. So we found that we performed such kind of collaboration. And we also compare with the results from the ensemble. If we compare with the results for GROSI-5 here with the ensemble, it looks like a little bit improved over this region. So we make a box to represent the Yangtze River in China. And the result is quite encouraging because it shows that during this period, the correlation coefficient between the predicted and the observed wind anomaly over Yangtze River basin is 0.76. And if we look at the, here it shows the two hydrological the station, then that measures the water flow, and we can find the river flow between the predicted and observed is also quite high. And if we compare the GROSI-5 with the ensembles, we can find there's also GROSI-5 performance quite good. Here shows the results for the GROSI-5, and here shows the for the ensembles. The GROSI-5 need a smaller the ensemble member. They can get the quite and also can get the quite good skill. And then the region is the question is what's the reason for such kind of improvement? At first, we check the subtropical high. We also use the Bin-Wang's index, and we can find the GROSI-5 is quite good with 0.84, but it's lower than ensembles. Ensembles show a very high, so a very high value. So subtropical high is not the reason for such kind of improvement in GROSI-5. And we showed just now. We showed that here shows that the SST anomaly related to Yangtze River Valley summer rainfall. Actually, this is some kind of, as I mentioned, it's related to the Western North Pacific monsoon mode, something like this one, positive SST anomaly and negative anomaly here. And this is for the observation. Here shows the precipitation, and this for the GROSI-5. This for the ensemble's result. We can find the GROSI-5 captured this kind of observed pattern quite well, especially over the Yangtze River here. So that means the GROSI 5 can capture very well between the SST anomaly and the rainfall over Yangtze River. And also it improved such kind of captured such kind of positive anomaly related to subtropical high. And this kind of teleconnection can be also shown by the vertical structure along this longitude. We can find that such kind of teleconnection in observation can be better captured by the GROSI 5, but not so good for the ensembles. Here shows the wave activity, and this for the observation, this for the GROSI 5, and this for the ensemble. Ensemble is quite weak compared with the GROSI 5. So for the summary, my conclusion is that currently the coupled model will predict the interannual variability in the Western North Pacific the summer climate, even for the neutral ENSO, but expect the La Nina decaying. Second, the prediction skill increased significantly around the late 1970s and mid 1990s. This kind of decadal change may be related to the Indian Ocean and Western North Pacific relationship, and also for this decadal change, this is related to a dominant Western North Pacific summer monsoon related variability. And final one is that GROSI 5 show a significant improvement and useful the prediction skill for Yangtze River Basin, summer rainfall over this basin, compared with the previous forecast system. Basically, that means that the ensemble system. For the reason we believe that the better teleconnection between the tropical SST and East Asian summer rainfall are shown in the GROSI 5. Yeah, that's it.